What is chemosynthesis? Chemosynthesis is the synthesis of organic matter using the chemical energy released by the oxidation of inorganic substances. This process is an alternative method of energy production that does not rely on sunlight. Organisms that produce their food through chemosynthesis are called chemosynthetic organisms. How was our planet formed? Protoplanetary disk formation. Imagine a young star surrounded by a swirling disk of gas and dust. Most matter spirals inward, feeding the star, but lucky dust particles collide and form pebbles. Planetesimal building blocks. These pebbles aggregate into larger objects called planetesimals. In colder regions, ice particles join the mix, forming giant planetary cores like Jupiter and Saturn. Terrestrial planets emerge. Closer to the star, rocky planets, like Earth and Mars, begin to take shape. Gas giants leave little gas for terrestrial planets, so rocky worlds take millions of years to form. The magma ocean era. Earth's early days were fiery. A vast magma ocean covered the surface. As our planet cooled, a thin crust solidified, and volcanic eruptions released water vapor. Birth of oceans. Condensed water vapor fell back to Earth as rain, creating the first oceans. Cosmic ice delivery. Ice molecules from asteroids and comets also contributed to Pyxis's water supply. These celestial icebergs melted upon impact, shaping our blue planet. How did chemosynthetic life begin? Our early planet had a reduced atmosphere with methane, ammonia, hydrogen, and water vapor, which were essential for the development of chemosynthetic life. Early prokaryotes, which are simple, single-celled organisms that appeared about 3.5 billion years ago, formed the basis of Earth's biosphere. Some of these prokaryotes evolved into chemoautotrophs, which produced organic food using energy from inorganic chemical reactions, similar to modern anaerobic bacteria. These organisms emitted CO into the atmosphere. Chemosynthetic life likely originated in chemically rich environments like hydrothermal vents on the seafloor. How does this planet work? Hydrothermal vents. Imagine cracks in the seafloor, releasing hot water like underwater geysers. These are hydrothermal vents, formed near mid-ocean ridges or tectonic plate boundaries due to magma pushing upward and creating fractures. Seawater circulates through vents, getting heated and enriched with chemical elements: iron, sulfur, copper. Chemosynthetic organisms thrive here, using altered minerals as their nutrition source. Brine pools. Picture dense underwater lakes with saltwater salinity much higher than the surrounding ocean. Brine pools often contain hydrogen sulfide and methane, providing energy for nearby chemosynthetic life. These hidden oases support unique deep-sea ecosystems. Mud volcanoes. Mud volcanoes erupt mineralized water and gases from beneath the surface of the planet Pyxis. The mud slurry, a mix of hot water and underground minerals, rises through fractures. Unlike fiery lava, mud volcano temperatures remain lower but are rich in minerals, feeding chemosynthetic organisms. Cold seeps. Cold seeps occur on the ocean floor where fluid seepage happens. These seeps often form brine pools rich in hydrogen sulfide, methane, and other hydrocarbons. Surprisingly, the temperature near cold seeps can be slightly higher than the surrounding seawater. The biosphere and possible evolution. Our planet's biosphere is very diverse and also prone to mutation and evolution because chemosynthetic organisms are resilient due to their adaptation to extreme environments and feeding on chemicals.